Bismillahirrahmanirrahim. So today, inshallah, we are going to start the chapter work, energy, power. Okay. Now the first topic that you have in this chapter is work. From SSC level, you know the definition of work as the product of force and
displacement.
displacement. Very good. Work is the product of force and displacement. Okay. Now we are going to take a deeper look into this. Now force and displacement, both of them are actually vector quantity. We know that, right? Distance is a scalar quantity, but displacement, this is a vector quantity, and force is also a vector quantity. So definitely there will be some direction involved, right? So if a body is like this, okay, and you are applying a force on this in this direction, and the displacement is being caused in this direction, let us say the displacement is S, then okay, you can say that the work done is F into S, no problem. Okay, this is the situation that we have till now. We have studied this type of situation that we are applying the force in a certain direction and the displacement is taking place in that direction. But what if the displacement is taking place in some other direction? Then what will happen? Okay. Okay, now let us say you are applying the force in the same direction, but the displacement is taking place in some this direction. Okay, so this displacement can be resolved into two perpendicular components, right? One is in the horizontal direction, another one is in the vertical direction, right? Because as the body is moving along this line, it is covering some horizontal distance, it is also covering some vertical distance. Now, on which one the force has some effect? Okay, due to this force, which one is being caused? Can you tell me whether the horizontal distance is being caused due to this force or the vertical one? Which one is being affected due to this force, or which displacement is being resulted by the application of this force? Can you tell me?
Horizontal.
Horizontal one, very good. Now imagine if there was not this force, then what would have happened? This body might have gone in the upward direction only, right? Now as we are applying some force on it, it is moving at some distance and it is covering some horizontal distance also, right? So the effect of this force is in the horizontal direction. So if this angle is theta, then what will happen? It will be S cos theta. That means the angle between the force and displacement is theta. Okay, this component will be S cos theta and this component will be S sin theta. Now, actually, according to the actual definition of work, if you go through it, okay, if a force acts on a body and causes some displacement along the force, what is the displacement that is being caused along the force? S cos theta. If I tell you to find out the work now, you cannot multiply F and S. You have to multiply F and S cos theta, because this is the displacement that is along the force. S sin theta, this displacement is not along this force, so this will not contribute to our work. If you want to say what is the work done by this force, you have to multiply this force into S cos theta, because this is the displacement that is being caused due to the application of this force. Do you understand my point?
Yes.
Yes.
So W will be Fs cos theta, given that theta is the angle between the direction of force and the direction of displacement. Okay. Acha. Now, from we already studied scalar product and vector product, right? From there, what I can write? Should I write F dot S or F cross S? Which one? Cos theta, what does it tell you?
Dot S.
Dot. Very good. This is dot product. Moreover, from one thing we can understand that in dot product only, we get a scalar product, okay, by multiplying to vector quantity. If I multiply to vector quantity and the resultant is a scalar quantity, then we can say that the multiplication was a scalar product or a dot product, right? As we know that work does not have actually any direction, right? If I ask you that how much work you have done, you will only tell me the amount of work that you have done. What is that amount of work? Like 20 joule, 50 joule. You will never say that, sir, I have done work 20 joule in the upward direction. Work doesn't have any direction, right? So work is a scalar quantity. So when you multiply to scalar quantity, sorry, to vector quantity, and you get a scalar quantity, that is scalar product or dot product. That is by f dot s. Okay. Acha. So here, if I want to write it in words, then what it will happen? How it will be? Force. F is force, right? So force into the displacement, the component of displacement. This is displacement. The component of displacement along the force. Okay. Component of displacement along the force. Understanding this one is of utmost importance. Displacement along the direction of force. Okay. Before I move on, let me make sure that anybody has any doubt in this.
No.
No, sir.
Okay. Acha. The dimension and unit, I don't think we need to talk about it anymore, right? Unit is joule and the dimension is m L square T inverse 2. You already know these things, right? Do I need to discuss it again? If you want, I can show you, no problem.
No, sir.
No, sir.
Acha. Now, for 2 marks, one question might come. Let me discuss that. We know that the unit of work is joule, the unit of force is Newton, unit of displacement is meter. So what I can write from here, 1 joule is equal to 1 Newton meter, right? Now sometimes in B, there might be a question that what do you understand by 50 joule? They will ask you, or they will ask in this way that write the significance of 50 joule. They both mean the same thing. What do you understand by 50 joule and what is the significance of 50 joule? It means the same. So if the question is like that, then how will you write? 50 joule means 50 Newton meter, right or no? So it might be put in this way that if I apply 50 Newton force on a particular body and the displacement caused along the direction of the force is 1 meter. So 50 into 1, I will get 50 Newton meter. Then I can say I have done 50 joule of work. Do you understand? Or I might say if I apply 1 Newton of force and the displacement caused in the direction of force is meter. So 1 into 50, again I will get 50 Newton meter. So I can say that I have done 50 joule of work. I may put different values. Like if I apply 25 Newton force, then to get 50, the displacement has to be how much?
2 meter.
2.
Very good, because 25 into 2 will give us 50. Or you might put different value like 5 Newton and 10 meter. 5 into 10, it will be 50. Whatever the value you put, you have to just make sure that when you multiply the force and the displacement, you get 50. If it is 50 joule, they are asking. It might be 30 joule, 75 joule, anything. Okay, you just need to take care that when you multiply them, the resultant is the figure that they are asking for. Okay, understood? So whenever you apply a 50 Newton force on a body and the displacement caused along the direction of force. Please remember this one to write. It was not there in SSC level, okay? Because we were not considering any displacement, other than along the direction of force, right? We thought that, or we considered that we are applying the force and the displacement that is being caused is along the direction of force. But now we will see on a particular body, several forces will be acting, okay? Definitely, if a body is going in this direction, either a force is being applied in this direction directly, or it might happen that a force is being applied in this direction, another force is applied in this direction. So due to the action of these two forces, resultant displacement is taking place in this direction. Due to this force, it is going in the upward direction. Due to this force, it is going in the rightward direction. And as a result, it is moving. It is both covering a distance horizontally and vertically, right? Now, if I ask you calculate the work done, you will calculate two work done, right? For this force, you will calculate one work done. This force, you will get another work done. Okay? So please remember. Acha. Okay. So do not forget to mention that the displacement along the direction of force. Mentioning this one is very important. Okay. Now, in page number 286, they have actually discussed about some unit of work and energy, like erg, foot-poundal, gram centimeter, foot-pound. These are the unit that used to be used in the previous time, okay? What we use now is Newton meter or joule, right? From this Newton meter, we can convert to foot-poundal, no problem. We can convert to gram centimeter. We just need to know the value of the conversion. So I would like to request you to go through it, because several MCQs might come. Like one MCQ is important, that 1 joule is equal to how many erg? It is 10 to the power 7 erg. Okay, so like this, there are several MCQs are there. I want you to go through it. No matter if I just tell you the value, you have to memorize it anyway. Okay, there is nothing much to understand actually. So try to do like this. Take a piece of paper, okay, and write as MCQ. Not as MCQ, maybe you write the question and just the answer. If you try to write as MCQ, you might have to write 4 options and then put the tick mark. That will be a waste of time if you're doing it yourself. So that is why I want you to take a piece of paper, take it as a homework or assignment, okay? Write that 1 joule is equal to how many erg. In below, write the answer. Do not write side by side, just write below, so that whenever you revise, you can just hide the answer and check yourself. Do you understand?
Yes.
Yes.
Okay, so do it for this page. Several MCQs are there. Acha. Now, work done by the force or positive work, and the next topic that we're talking about, and work done against the force or negative work. The best example that we can give for this to understand, let us say this body, I am pulling, I'm taking it in the upward direction. Can you tell me what are the forces or how many forces are acting on this body? If I'm taking it in the upward direction, how many forces are acting on this?
Gravitational force.
Yes, number 1, gravitational force. Another is any other force working on this?
Y-axis.
Definitely there is a force that is exerted by me on this body, for which the body is going in the upward direction, right? If I want to move it in the upward direction, I have to apply a force in the upward direction, right or wrong?
Yes.
Yes, right.
So 2 forces are acting on this body. If a certain body is going in the upward direction, this is one force that is being acting, and the displacement is taking place in this direction. And another force is acting, that is the force of gravity. Okay, we can just represent it by Fg. So now if I ask you, okay, which one is work done by the force and which one is work done against the force, you will judge that by the direction of the displacement and the direction of the force. Here you can see the direction of the displacement and the direction of the force, okay, that is applied by me are in the same direction. That means the work that is being done here is by the force that I am applying, right? So what the work I'm doing, that is positive work. But think about this way, the force that is being applied by the gravity or the earth is gravity, right? So this gravity and the displacement is in the opposite direction. So this is a work done against the force, okay, because it is in the opposite direction. And here the work done is going to be negative. You might think, sir, how work done will be negative? Work is a scalar quantity, right? But still it can be negative. How it can be negative? Let's see. We already got to know that the actual equation of work is W is equal to Fs cos theta, right? So whenever the force and displacement is taking place in the same direction, the angle between them is actually 0 degree, right? Both of them are in the same direction, parallel. So 0 degree. So cos 0 has a value of 1, so it will be F into S, okay? Now, when the force and the displacement is taking place in the opposite direction, can anybody tell me what is the angle between them?
9.
180 degree.
180.
180 degree. Because if the force is being applied in this direction and the displacement is taking place in totally opposite direction, that means the angle between these two will be 180 degree. So put the value of theta as 180 degree, Fs cos 80 degree. Do you know what is the value of cos 80? 180. It is -1. Okay. So it will be minus F into S. So when you put the value, you are going to get the value of work a -1. Okay. So this is work done against the force. Whenever you get minus work, that will tell you that the force that you are considering here, okay, is actually in the opposite direction of the displacement. Do you understand positive work or negative work?
Yes.
Okay. Acha, I need to take the attendance. We got to know about positive work. We got to know about negative work. In between positive and negative, what is there? Positive.
Zero.
Neutral.
Zero. Very good. So is there anything like zero work? You might say that yes,
No
sir, I might
is
be-
done. No work is done.
no work is done, right? When there won't be any work done.
When no force will be applied.
কোনো displacement হবে না.
Two cases. Very good. Very good. The two cases that you know till now, that if I don't apply any force, no work will be done, zero work. If I apply some force but no displacement is taking place, then also no work, right? Like if I apply force to the wall, no displacement will occur. So as a result, what will happen? No work will be done, zero work, right? But what if I tell you that the force is being applied, the displacement is also taking place, still the work done is zero? That is also possible. Let me show you how, okay? Zero work. Even though you are applying some force and some displacement is taking place. Notice that I'm not saying that displacement is taking place along the direction of force. See, interesting. If this is the object and this is the force that you are applying and the displacement that is taking place is along vertical direction, then actually the work done is going to be zero. Because due to the application of this force in the horizontal direction, the object is not covering any displacement, not covering any distance, right? The displacement does not have any component along along x-axis or horizontal direction. Do you understand my point? This is actually is similar with our common concept that we apply some force, but there is no displacement. No displacement is occurring along the direction of force. You are applying some force in this direction, but here you see it is not covering any single direction, any portion of distance in this direction. It is just simply going in the upward direction. So you keep applying the force in this direction, but it is not having any effect on this body. It is going in the upward direction under the influence of some other force maybe. Okay, so this is the case. Now mathematically how can we prove that the
90 value 0 তাই cos 90 এর value 0 হয়
cos 90 value 0 type? Very good. If I want to show it mathematically, then it will be like this, that fs cos theta. Now as they are perpendicular to each other, the angle between them is going to be 90 degree. So cos 90 has a value of 0. So the work done will be 0. See what I said, the force is being applied, some displacement is also taking place, but still the work done is 0. Why? Because due to this force, no displacement is occurring in the direction of the application of force. Do you understand my point? If you
Yes.
say that this due to this force you are doing some work or some work is being done, there must be some displacement along the direction of the force, application of force. Okay, as there is no displacement along the application of force, it is just moving in the upward direction. Okay, খেয়াল করো যদি এটা অল্প একটু হইলো এইদিকে যাইতো তাইলেও আমরা বলতে পারতাম যে আমরা কিছু কাজ করতেছি, বিকজ এটা যখন এখান থেকে ওখানে যাবে তুমি দেখো এটা কিন্তু কিছু হরিজন্টাল ডিসটেন্স কভার করছে, তার মানে along the direction of force it has covered some distance, so then we could have said that it has done a small amount of work at least. But now the condition is it is just going in the vertical in the upward direction, so you cannot say at all that some work has been done. Clear?
Yes.
yes
Okay, so these are actually work done by fixed amount of force, constant force, like whenever we are saying that some force is being applied on this one, let us say for 5 seconds we are considering, for this 5 second constantly 5 Newton force is applied on this one. This is what we consider when I say that I am applying some force. But there the case might be a little bit different, that whenever I'm applying some force, initially it might be large amount of force, later when it got into motion the force was decreased. So now that is the case of variable force, work done by variable force. That topic is not what we are going to discuss today. Inshallah, this is the topic we will discuss in the next class, that is in page 289. So I would like to request you to go through page number 284, 85, 86, 87 and 88. So 284 to 288. Kindly go through these pages. Whatever is there, I have already discussed and gave you the main idea. Okay. All I want you to do is go through the lines of the textbook and check if you find any line or any word that you don't understand. Okay. So please go through it and let me know if you have any doubt in any of the line, okay, or any of the equation that you didn't understand. Okay.
Okay, sir.
Okay, then
Okay.
inshallah in the next class we will start from work done by variable force. Okay, we have a very less amount of time left. I don't think if I start today I can finish the derivation of this. Okay, so see you in the next class inshallah. Before we end this class, anybody wants to ask anything about what we discussed today?
no
Okay, Alhamdulillah, I think everyone got the idea. And please inform your friends to attend the class regularly, as the attendance is being taken and it is being recorded that who is missing class on a regular basis. Okay, thank you very much.